Hello there, Algebras, and welcome to the Chapter 1, Lesson 7 notes. So today we are going to be solving literal equations and inequalities. So we first need to realize that literal equations are equations that are more general, meaning they have more variables involved. So they're typically formulas, okay? And formulas have a whole bunch of variables throughout them because they're just giving you the relationship of several different pieces that all plug into this thing together and have this specific relationship. And so when you know that about a formula, when you know these are the variables, this is their relationship, and you know what a few of those variables are equal to, you can figure out what this missing variable is equal to. And that's what solving literal equations and inequalities is all about. It's about getting this one specific variable alone amongst many variables. Okay, and what is that relationship to this one variable to all these other variables in the formula? All right. Give 3 examples of formulas. So if we were in person, we'd be brainstorming a bunch of different formulas, but I'll give you some of the popular ones that come up year after year after year when doing this. And my starting with that one would be a squared plus b squared equals c squared. And that, of course, is the Pythagorean theorem. So this is the Pythagorean theorem formula. This is the legs in a right triangle squared and added up are equivalent to the hypotenuse in a right triangle squared. And so that's telling me the relationship between the 3 legs in a right triangle. And this is a piece that you have seen in previous years. So there's a little sample of a right triangle with my A and my B as my legs and my C as my hypotenuse, always that biggest side, right? That's one example. Another example that everyone loves to give me, even though, we're not really in physics yet, is E equals mc squared. So Einstein's famous formula about the speed of light, mass and energy, right? So energy is equal to the mass of your object times the speed of light squared. That's how much energy it has. Everyone loves to give that particular formula. And the other one that everyone always wants to throw out there, and it's true, this is a formula that we look at, is y equals mx plus b. And this would be the point slope formula. So this is the equation of a line with a slope and a y-intercept involved. And the x and the y are each of the points that make up this line with this slope and this y-intercept. And so again, each one of those 4 variables has a meaning, and this is the relationship between them. You can find the y if you know the slope and the point, or the slope and the y-intercept, you can find the x and the y. And so that's what we kind of do, is get one of these variables by itself and use that relationship to then help us with knowing the rest of those numbers, figuring out a missing value. Okay, so what I'm going to do for you first is I'm going to solve one of these regular linear equations, and I'm just going to show you the opposite operations that I'm using each step that I'm doing. I'm going to do something funky as I do it. So I'm going to go slow, and I want you to do the same thing on your paper. And this is what I would do if we were in person as well. Okay. First things first. What do you want to do to get 2x alone? And someone in here would say, oh, I want to add 6 to both sides of the equal sign. Done. Let me do it. I'm going to add 6 to both sides of the equal sign. Cool. That's the additive inverse. The additive inverse of -6 is +6. And adding it to both sides of the equal sign is the addition property of equality. So I'm doing it right now. What would you do? These have canceled out to 0. This comes down to the next line. Bring down your equal sign. And then over here, you've then got 10 plus 6. Normally, you would actually add that 10 plus 6 because they're like terms. But bear with me. This time, leave them separate like this. Now, what would you do to get x alone? What is the opposite of multiplying by 2? Dividing both sides of the equal sign by 2. So let's do it. Divide both sides of the equal sign by 2. These 2's cancel out because they are multiplicative inverses. And you did it to both sides of the equal sign, so that's the multiplication property of equality. You end up with 1x equals whatever 10 plus 6 divided by 2 is. Can you actually add 10 plus 6? Yes, you get 16. What is 16 divided by 2? Can you actually divide 16 by 2? Yes. What do you get? You get 8. So notice in this case, because I had all numbers, so they were all like terms, they were all real numbers, they're all like terms that can actually add and subtract and multiply and divide, I can narrow that down, combine all those terms into one real number as my answer for this equation. But what I want to show you, again, I'll zoom back out so you can see, these two equations are set up with exactly the same operations. So I will use the exact same opposite operations with my variables. What's the opposite of subtracting 6 from both sides? Adding 6 to both sides. So what's the opposite of subtracting b? Add b to both sides. That's the additive inverse of negative b is a positive b, and doing it to both sides is the addition property of equality. Okay, these b's cancel out and leave you with just ax. Well, here's what I was trying to point out over here. These were like terms, so I could eventually add them. These are not. So why we call these literal equations is we literally rewrite c plus b on this line. That's it. That's what's different now. That's the only thing that's different now. I know that people struggle with this, but it's actually easier because I don't have to know how to add. Those are two separate things that don't add up, so I leave them separate. Just know that they're going to add at some point, right? I want x alone. I was told to solve for x. Okay, well, right now a is multiplied by x. So what's the opposite of multiplying by a? Dividing by a. So I divide both sides of the equal sign by a. There you go. That is multiplicative inverse. And I did it to both sides, so that's the multiplication property of equality. See, same operations are occurring. Now you've got x all by itself, which is exactly what you wanted. Since none of these are like terms, nothing can simplify, nothing can actually add together, nothing can actually divide, all I do is literally rewrite c plus b divided by a. That is my answer. So I just want you to see that this is no different than when you have all variables. You know how to do this. You know how to do this. Okay? Compare our work. Did you have to do anything different? No. It's exactly the same. Exactly the same operations. Okay? It's exactly the same operations. So now, okay, let's keep in mind that variables are placeholders for numbers, real numbers, and we know the properties of real numbers and we know the properties of equality. So we are using those to get our variables alone. Okay, and that's still a thing. The most important piece about solving literal equations is knowing which of, see, there were 1, 2, 3, 4 variables in this problem. Which of those is the one you want to solve for? So which of those 4 variables is the one you get alone? That's the most important thing that you need to know going into this. Which of those to get alone? And then, again, because these have the same properties as our regular real numbers, variables have the same properties as regular real numbers, you need to use those same ideas using your opposite operations, okay? Getting that variable alone. Keep in mind, if you are using an inequality sign instead of an equation, instead of an equal sign, if you divide both sides by a negative, you still have to flip your sign. And so that's the only real trick that might occur in anything that we're doing here. But I will show you an example where we would know we're dividing by a negative. Okay, so I'll tell you about that. First, let's use another formula that we should probably know, right? The perimeter of a rectangle can be found by using the formula P equals 2L plus 2W. Perimeter, length, width. And just think about that with a rectangle. Length, width. How many lengths are there in a rectangle? Well, there's 2 of them. How many widths are there in a rectangle? Well, there's 2 of them. How do you find the perimeter of something? You add up all the outside sides. So there you go, 2L plus 2W. We want to solve the formula for the width, which is W. So right here, we're being told which variable to get alone. So in P equals 2L plus 2W, get W alone. That's the one we want to have alone. So just remind yourself of that. Get W alone. Well, how is the 2W currently attached to the 2L? They're attached through addition. What's the opposite of a positive 2L? Let's move it as a negative 2L. So let's subtract 2L from both sides of the equal sign. Opposites, right? Cancel out to a 0 over here. Literally rewrite P minus 2L equals 2W, the only thing left over here. Now again, you're trying to get W by itself. How is the W attached to the 2? By multiplication. What's the opposite of multiplying? Divide by 2. So 2 divided by 2 cancels out to a 1, which is what we wanted, a 1W. And over here, now I see that there's a 2 over 2 here. But remember, unless you also have that here, unless you also have that over here, you cannot take that out of all the terms. So just literally rewrite all this, okay, on this line. P minus 2L over 2. That is the relationship to one width compared to the perimeter and the length, okay? So if you know the perimeter and the length, you can use this relationship to immediately find the width. All right, that's why we rearrange these formulas. That's why we solve these literal equations. All right, flipping. Okay, here's another one. This is the area of a trapezoid formula. So the area of a trapezoid formula is area equals 1/2 of base 1 plus base 2 divided by the height. And if you don't remember a trapezoid, that's this guy. Trapezoid has 2 parallel sides, and those parallel sides are connected by sides that are not necessarily parallel, okay? Not necessarily equal, not necessarily parallel. So it's a 4-sided figure where this is base 1, which has a separate length from base 2. And the height is from base 1 straight down, creating a right angle with base 2. So that's what a trapezoid looks like. Those are the pieces. The area is all that's covered on the inside of the trapezoid. Okay, so the covering of the trapezoid is its area. Now, what we're going to do is we're going to take this formula, and again, we're told right here, solve for B2. So the point is to get B2 alone. Always know which variable you want by itself. That's how you start. Now, this looks really complicated, and I'm promising you, this is not. Take it one step at a time. Don't try to barrel in. Try to think about what you know. And the first thing you need to know is that multiplying by 1/2 is the same as dividing by 2. So what is the opposite of dividing by 2? It's multiplying by 2. Start off by multiplying both sides of your equal sign by 2. That's the multiplicative inverse there. So over here, you've got 2a. Bring it down to this line. Over here, the fraction has canceled out. So you've got b1 plus b2 in parentheses times h outside. Leave b1 and b2 right now. Move the h. What's the opposite of multiplying by h? Divide both sides by h. Now the h is gone. And you've got 2a over h equals b1 plus b2. How do you get b2 alone? Subtract b1 from both sides. So I'm going to need a little bit of space here. We're subtracting b1 over here, right? Subtracting b1 with this guy. So these cancel out, and you get that b2 is equal to 2a over h minus your b1. That's the relationship. And I'm okay with having brought it down to this line because find the length of b2 if you know the area, you know the b1, and you know the height. So actually, take what you just did and plug those in. 2 times the area is 78, the height is 6, and the b1 is 8. So that is what we are going to then plug into our graphing calculator. So notice I have it pulled up right here on the screen. If you're using a Chromebook, you have the graphing calculator app that you can be using. Okay. I also have a graphing calculator right here, right on my desk. So I have them in a couple of places. So over here, graphing calculator. Oh, I can't make that any bigger. Sorry, guys, that's the screen. So I'm going to plug in the top. I'll start there. 2 times 78 is 156. Okay. Now we have to divide that by 6. So 156 divided by 6 is 26. And now we have to subtract 8 from it. So we've got all that written out already. What do we get? We get that B2 equals 18. So with this information, notice the variable you don't know is B2. So all that got plugged right in there to find what B2 was equal to. So we're saying that that's the relationship. And here is a place where you know all of the variables except B2. So here's a place where this gets applied immediately. Just a heads up. This is a former Regents question. So this is something that was 4 points on a Regents exam in the past. So you want to make sure you know how to do all those pieces. Now, if you got there and you weren't really sure how to do this first part, you could still do this part, the plugging into the formula, just fine. But to get the full points, you needed to know how to do both. Okay? And so former Regents question, that's why we lace those into our notes and our homework so that you have a good idea of what questions kind of get asked and also how to tackle them when they do get asked. Okay. So now let's do a couple more examples of getting our variables alone. Let's see how this one's worded. So if 2a times b plus c equals 15, solve for c in terms of a and b. So in this question, which is how the Regents has a tendency to ask these, they told you what all 3 of the variables in the equation were. Like you couldn't see them or something. I don't know why they had to tell you all of them. But what one did they tell you to solve for? C. So which variable is going alone? C. Get C alone. So right now, let's think. How is the 2a attached to the b plus c? It's attached by multiplication, right? What's the opposite of multiplying by 2a? Divide both sides by 2a. So divide both sides by 2a because those are multiplicative inverses. Now again, these are not necessarily like terms, so leave them be, leave them where they are. Bring down the b plus c, bring down the 15 over 2a. And now again, you're getting c alone, so it's the opposite of having a positive b. Subtract b from both sides. They cancel here. C equals, literally rewrite 15 over 2a minus b. Okay, literally rewrite these things. Do not try to do that combining of like terms. Excuse me, do not try to do that combining of unlike terms because you can't. What is y in terms of the other variables? And notice I didn't even bother reading the other variables. I want to know what y is. So what variable needs to be gotten alone? Y. Know that going in. Know which variable needs to be alone. So I'm just going to rewrite because I like to do that. So, okay, let's start. What's the opposite of adding k? Subtract k. So subtract k from both sides. So e times y over n equals t minus k. Literally rewrite. Lots of variables here. Don't panic about fractions. The opposite of multiplying, or excuse me, the opposite of dividing by something is multiplying by something. So right now we're dividing by n. Just multiply both sides by n. There is no need to panic about that. Now you've got ey alone. And on this side of the equal sign, you've got this t minus k being multiplied by this n. So if you want to distribute that n, you can. And if you want to leave that n where it is, you can. Either of those is fine. Now, you're getting y alone. What's the opposite of multiplying by e? Divide by e. None of these terms are like. None of these terms have to combine. So I can leave it just like this. Oops, sorry, that looks like an L down there. That's an E. My bad. Or if you wanted to, you can distribute your n. So it can be nt minus kn over e. So either of these is fine as your answer. Again, it's an or situation. Okay, you don't have to distribute that n. You can if you want to. I just want to make a note, and in chapter 6, we go through this extensively as to why, but I write my variables that are multiplying together in alphabetical order. So we'll talk about why in chapter 6, but that's just something I do, okay? To make sure we've got like terms there. Inequalities. We haven't seen an inequality example yet. The only thing you have to worry about with these that's different is if you know you're multiplying or dividing by a negative number, you have to flip your inequality sign. So if a problem tells you that one of your variables is smaller than 0, you know it's negative. Okay? I know that a is a negative number going into this. Now it tells me solve for x in terms of the other variables. So get x alone. What's the opposite of what's the opposite of dividing by c? Multiplying by c. C is not a negative number according to this problem, so I don't need to do any sign flippage by doing that. Now, of course, add b to both sides. There wouldn't be any sign flippage with adding and subtracting anyway. So I literally rewrite. Now, in order to get x alone, because I'm solving for x, I know I've got to divide both sides by a. And what did I know at the beginning of the problem? A is negative. So now is where I have to think about that sign. Because I divided both sides by, oops, that's an A, my bad. There you go. I divided both sides by A. And I know that A is negative. So I know I have to flip my inequality sign over. Typically, when you encounter this, this is a former Regents question as well. Okay? That's a former Regents question as well. Typically, when you do encounter that, that's what they're testing you on. Is do you remember that this negative number is being divided on both sides or is being multiplied on both sides and that you have to flip your inequality sign over? One more, and I'll leave this example up and you can see all my other examples, just opposite operations. B is less than 0. That means B is negative. Okay? Solve for x in terms of the others. So cool, x is what I have to get alone. It's in parentheses right now. What's the opposite of multiplying by b? Dividing by b. That's how I'm going to start. I'm going to divide both sides by b. Ax plus c is less than negative 3 over b. All right, now let's just subtract c from both sides. Ax is less than negative 3 over b minus c. Oh no, what did I do? What did I do? Right from the get-go, I just got done saying it to all of you. This needs to be a greater than. See, you gotta watch it. I multiplied by b right away. There you are. Have to flip that sign. Because now, at the end, I don't know that a is negative, so I can leave this sign as is. And I would just literally rewrite this. X is greater than. See that sign flip had to happen? See, this is what happens. Minus c all over a. And as of right now, I don't know that A is definitely negative, but I did know that B was definitely negative. So when I immediately divided by B, that should have been the first thing I was doing, was flipping that sign. See? Watch that. Don't you make that mistake when you go do your homework. All right? Okay. So there you are. Same exact operations, opposite operations. Same thing as when you're multiplying or dividing by a negative in an inequality. Flip that inequality sign over. But otherwise, you got this. This is the same operations that you would use. Again, think back to this first example we did together. It's the same operations happening whether you've got numbers and only one variable or whether you've got multiple variables involved. So tonight's homework will be multiple variables involved. There's one question that I start off, it's just like this, okay, where you compare the two, and then the rest is multiple variables involved. Okay? Come to office hours if you need me, guys. Good luck, though. I think you'll be all right. You can do this. You can do those opposite operations. And I will be seeing you soon. Have a great day.